at ions. So, an ion, what is the definition of an ion?
It's an ore. An atom that has lost or gained electrons.
So it's a charged atom, and it is an atom that has lost or gained electrons. Could be one or more electrons. So a cation, what's a cation? A cation is a positive ion, positively charged ion. And what's an anion?
It's a negatively charged ion.
Negatively charged ion. All right, so the next logical question to ask is, how do we get an ion, and what types of atoms form different types of ions? Wojciech.
It's typically found 22 blocks below the surface, and iron ore can be mined.
Okay, that's an interesting answer that will be, I'm assuming, is related to that weird game called Minecraft. And I think that we are dealing with the wrong type of ion. So, the ion I'm talking about is ION, not IRON. So, yes?
So you can get an ion for static electricity.
No, I was just quoting Isaiah
Electrons,
7:11.
the electrons go from one surface to the other.
Okay, yep. What else? How do ions form in a permanent basis? Okay, so electrons want to have 8 electrons in their outer shell, except for hydrogen and helium that want 2 electrons in their outer shell. So electrons are always trying to achieve what is known as a stable octet. So they want 8 electrons in their outer shell. And one way they can do this is by forming ions. So ions, so if we've got fluorine here, how many electrons does it have in its outer shell? 7. What does it need to do to get 8 electrons in its outer shell?
Get another electron.
It needs to gain an electron, doesn't it? So it needs to gain an electron. If it gained an electron, what charge would it have? Negative what?
Electric charge.
How many negative charges?
Minus
Negative 1.
77.
So let's look at this one here. What did we say that was? That was sulfur. So sulfur has how many electrons in its outer shell?
6.
How many does it want in its outer shell?
8.
How does it get 8 in its outer shell?
By gaining 2 electrons.
Gain 2 electrons. If it gains 2 electrons, what will its charge be?
Minus 2.
-2. So this one here is oxygen. How many electrons does oxygen have in its outer shell?
6.
How many does it want to gain? 2 more to get 8. So what will its charge be?
Minus 2.
So oxygen and sulfur are in the same group, and they form ions with the same charge of -2. Let's come over to group 1. So lithium has got how many electrons in its outer shell? 1. For it to have a full outer shell, what is the easiest way for it to have a full outer shell?
By losing an electron.
By losing an electron. It can't gain 7 electrons to fill its outer shell to 8, so it's going to drop an electron to have a full outer shell. And in this case, the full outer shell will be the inner shell with 2 electrons, which is full, and it will be happy. So if it lost an electron, what would its charge be? +1. So group 1, group 2 and group 13, these form cations. So group 1 will form a +1, group 2 will form a +2, and group 13 will form a plus 3. On the other hand, these ones will form anions. So what charge will the anion be on a group 15?
Negative -1.
How many electrons do they have in their outer shell?
600.
5. How many do they want in their outer shell?
7.
8. How do they get 8 in their outer shell?
By getting 3 more.
By getting 3 more, which will give them a charge of
8.
-3. We've already established this one will be -2 and this one will be -1. What about helium and, what's that one? Is that neon?
Yes.
So neon has 2 electrons here and 8 electrons in its outer shell. What is it going to do?
Nothing.
Nothing. It's happy. These ones are not going to form ions. And these ones in the middle tend not to form ions. They can form a +4 or a -4. We're not going to worry about those ones. So what we can see is that the cations are formed on this side of the periodic table. The anions are formed on this side of the periodic table. The group number tells you the charge. So if it's in group 13, it's got a +3 charge. If it's in group 2, it's got a +2 charge. If it's in group 1, it's got a +1 charge. If it's in group 15, it's got a -3 charge. If it's in group 16, it's got a -2 charge. If it's in 17, it's got a -1 charge. Okay? So that's what happens when we form ions, and we'll do a bit of a demonstration of it in a moment, but a question, yeah.
So does this affect the
Okay. So let's have a look at, say, sodium. No, which one do I want to look at? I'll have a look at, yeah, sodium. So sodium is in period 3. So it has 3 electron shells. It's in group 1, so it has 1 electron in its outer shell. So when it forms an ion, it loses this electron. So that electron gets lost, and we end up with a full, this shell then becomes the outer shell, that is full, and sodium will then have a plus charge. So where does that electron go? Rubs off somewhere. So,
A certain, or whatever it rubbed off.
so what if we had chlorine? So chlorine, which group is chlorine in? Which period is it in? Is it in period 3?
Yes.
So how many electron shells does it have? 3. How many electrons in its outer shell? 'How many electrons does it want to gain? 1. Where do you think it could get an electron from?
Down the road at Woolies.
Down the road at Woolies? Does it have to travel that far? Where could it get an electron from?
The ground.
From a sodium ion, from a sodium atom. So this electron from sodium gets transferred over here. So chlorine now has 8 electrons in its outer shell. Its outer shell is full. Is it happy?
9.
Sodium has 8 electrons in its outer shell. Its outer shell is full. Is it happy?
9.
So we now have a chlorine ion, which has got a negative charge, and a sodium ion, which has got a positive charge. What do you think is going to happen?
They're going to
They're going to join together. Positive charge, negative charge. Opposite charges attract. They're going to be bonded together in what's known as an ionic bond. And it forms sodium chloride.
So they get married and have a kid and call it sodium chloride.
Well, they don't create something new. So sodium chloride is formed through ionic bonding. Ionic bonding is when 2 ions come together as a result of the electrostatic charge. Yeah.
affect the conductivity of the elements?
Yes, it does. And we're going to do a practical on conductivity of ionic stuff next week. That's a good question.
That does sound fine.
Okay, so that's sodium and chlorine. What would happen if we had... Where can I draw this? I'll draw it here. Let's go with calcium. So calcium is in group 2, period 4. Okay, so we've got an electron configuration that looks like that. What does it want to do to get, how does it get a full electron shell, outer shell? It's going to drop 2 electrons. So let's say that we've got a chlorine over here, which I'm not going to fill in the inner shells, I'm just going to fill in the outer shell. So it wants to gain 1 electron, right? So we're going to transfer this 1 electron from the calcium over to the chlorine. Is the chlorine happy?
Yes.
Yep, so that's a Cl minus ion. Is the calcium happy?
No.
Why not?
Because
So how is it going to get rid of its other electron?
By going for a run.
they'll get it to another chlorine.
Another chlorine.
Yes.
One, two, three. So the other electron is going to go down here. And what have we formed?
Calcium chloride.
So we've formed calcium chloride. Is that the right formula? What would it be? CaCl2. Now, notice that it's calcium chloride, not calcium chlorine. So when we form anions, we turn the name into an ide. So oxide, fluoride, chloride, nitride, and so on. So this is calcium chloride. We need 2 chlorines for every 1 calcium, because calcium has a +2 charge, chlorine has a -1 charge. So to balance it, we need 2 chlorine atoms for every calcium, so we get CaCl2. Yeah.
Does the cation have its name changed?
No. No, so just calcium chloride. Yep.
What happens when it's in a state where it can't find another atom to bond to?
There's lots of atoms around. Yep. So you do get calcium as just as calcium, as the metal calcium, and that's formed by metallic bonds. And I don't think we're really going to talk about bonds, those type of bonds. We do that next year. Yep. Yep. Oh, could we have one chloride ion and 1 fluoride ion, and then we would end up with calcium chloride fluoride? Well, theoretically we could, yep, but it would be more common to end up with calcium chloride and calcium fluoride probably. Yep. Yep.
Sulfur as well? Can I go with sulfur as well?
Why are you interested in sulfur?
Because it's got 6 atoms on
Yep. And
and calcium has 2.
so then it would form calcium sulfide. And what would the formula for calcium sulfide be? CaS, because calcium is 2+ and sulfur is 2-, so we need 1 of each. So if we've got oxygen, what kind of an ion does oxygen form? Have a look on your periodic table. What would the ion be for oxygen? It's an oxide ion. What would its charge be? It'll be negative. Negative what? Negative 2. So if we've got an oxygen, which is 2 minus, if it bonded with an aluminium, what would the charge be on an aluminium ion?
+3.
Plus 3. Why plus 3?
Because it's there.
Because it's in group 3, it's in group 13. It's got 3 electrons in its outer shell. It's going to lose all 3 electrons. So it's going to be an Al3+. How many of each of these do we need to make a neutral ion, a neutral compound?
2 aluminium, 3 oxygen. Am I right? Yes. Okay. Oh wow. First time maths is so.
All we do to work it out is we swap these over and we drop them down. So it's called swap and drop. Simple process. We take the charge on the aluminium, we drop it down here. Take the charge on the oxygen, we drop it down here. So we did the same thing with sodium chloride because we had Na plus and Cl minus. We had one of each. So we've taken one, we've swapped and dropped. And we did it with calcium chloride. To get CaCl2, we took the 2 from here, swapped it down there, the 1 from there, swapped it down there. Okay? So we're going to do more of this because one of the things that is really poorly done in Year 10 is putting together ionic compounds and dealing with the charges. So I'm going to work with you guys so that when you're in Year 10 next year doing chemistry, you're going to have an easier time of it than what this year's Year 10s seem to be having.